Hi everyone, this is Rookie. Welcome to Math Key. Well, in our last lesson, we dealt thoroughly with all kinds of exponential equations. If you missed out on that or you probably want to have a better understanding of that concept, then feel free to watch this video. The link is in the description. Like we mentioned in our last lesson, in today's lesson we are going to focus on another special type of equations, logarithmic equations. The thing is, if you're a first timer to this channel, all we are asking for is that you click on that subscribe button for updates of recent videos. Now let's dive in. There is no way we can start talking about logarithmic equations without having a proper understanding of what the logarithm of a certain number to a certain base is all about. By definition, the logarithm of a certain number to a certain base is the power to which the base must be raised to give back that number. Instead of the use of letters, let's narrow down this definition to the use of numbers for the purpose of clarity. All we are saying is that the power to which the base 2 must be raised to give back 8 is the value of log 8 to base 2. From our knowledge of exponents, the base 2 can only be raised to the third power to give back 8, since 2 cubed equals 8. Hence, the value of log 8 to base 2 is 3. From this definition, we can therefore imply that log 64 to base 8 has a value of 2, since the base 8 can only be raised to the second power to give back 64. And also, log 16 to base 2 has a value of 4. Having understood the definition of the logarithm of a certain number to a certain base, what is therefore a logarithmic equation? This is just a type of equation in which the variable contains a logarithm. Here are other examples. One very interesting thing about every logarithmic equation is that it can easily be translated to exponential form. And how do we do just that? Very easy, of course. Let's just say we want to translate the logarithmic equation log y to base a equals x to exponential form. First of all, let's duplicate the equation so that we can easily compare both forms. To do this, the variable y maintains its position while the base a goes straight to the right side of the equation and makes x its power. Then we just get rid of the logarithm. Let's repeat that. The variable y maintains its position, the base a goes straight to the right side of the equation and then makes x its power. Then we just get rid of the logarithm. Super easy. Both equations mean exactly the same thing. It's just that while the first is in the logarithmic form, the other is in the exponential form. In the same way, if we wish to translate any exponential equation to its logarithmic form, all we need to do is to reverse the process. For instance, the exponential equation y equals 2 raised to power x has its logarithmic form as log y to base 2 equals x. So basically, this is how we translate between both forms of equations. In addition to this skill, we need to understand some of the various laws of logarithm before we proceed with problem solving. This law states that the logarithm of a product is equal to the sum of the logarithm of the individual factor. This means that log 5 times 7 in bracket equals log 5 plus log 7. This law can also be thought of as the law of distribution or the law of condensation, depending on whether we are moving forward or reversing the law. Also note that the law applies to as many factors as possible. This law states that the logarithm of a quotient is the difference between the logarithm of the numerator and the logarithm of the denominator. This is also more like distribution or condensation. This law states that the logarithm of a number to a certain power can also be written as the power falling behind and then multiplying the logarithm of the number to its base. So log 5 cubed to base 4 equals 3 times log 5 to base 4, which is 3 log 5 to base 4. And reversing this law, we can therefore write that 2 log x plus 1 in bracket is the same as log x plus 1 in bracket to base 3 and to the second power, since x plus 1 is grouped in a bracket. What about in a scenario whereby the base is the one carrying the power? Does the law also apply? Well, somehow the law does, but this time, instead of multiplying directly by the power, we multiply by the reciprocal of the power. So log 7 to base 3 square is the same as half log 7 to base 3. This law states that the logarithm of a number to the same base is always 1. For instance, log 2 to base 2 is 1. Log 8 to base 8 is 1, and so on. And lastly, the logarithm of 1 to any base is always 0. Let's now take a walk around a couple of examples. The first thing to be done when solving any logarithmic equation is either to translate the equation or condense it, depending on its nature. In this example, we are going to translate the equation to exponential form. From our knowledge of exponents, we already know that 32 is 2 to the 5th power. Since the exponents are now the same, then by comparison, the value of x is 2. Very easy. Let's take a look at another example. There are different approaches to this question, but we are just going to take it the easy way. From the power law, we can raise 81 to power half, which is equivalent to the square root of 81, and that's 9. We therefore translate this equation to its exponential form. We already know that 9 is 3 to the 2nd power. Again, since the exponents are equal, it implies that the value of x is 3. Let's get a little deeper. While it looks like this question is without a base, note that any logarithm without a base implies a base 10. So we introduce each of them. Since there are two logarithms to the same base, we have to condense them according to the product rule to have this. And after translation, it becomes 2 times x minus 3 in bracket equal 10 to the 1st power, or just 10. So we clear the bracket, collect the like terms. So 2x equals 16, which implies that x equals 8. This is also very easy, right? But let's get even deeper still. All logs have been written to the 6th base. According to the product rule, we can condense the left-hand side. And since we have log to base 6 of both sides of the equation, we reserve every right to eliminate both, as this does not alter the equation in any sense. So we clear the bracket and rearrange the terms to have this new equation, which is quadratic in nature. Thus, after factorization, it becomes x plus 19 in bracket multiplying x minus 2 in bracket equal to 0. Hence, the value of x are minus 19 and positive 2 for this equation. If you need assistance on how to factorize quadratic expressions, then be informed that we have specially prepared this video to guide you on how to go about that. Check out for the link in the description. So over to you. Having learned these simple skills, you should be able to play around this slight refreshment. I encourage you to pause the video right away and give it a try before we do it together. Welcome back. Let's check what your result is. We first condense the left-hand side, translate the equation to exponential form, expand the bracket, and of course, at the right-hand side, 2 cubed is 8. We collect the like terms, and the x squared equals 9, which implies that x equals plus or minus root 9. We already know that the square root of 9 is 3. Therefore, the value of x is either plus 3 or minus 3 for this equation. Let's take a look at the last example for today. In this example, note that we are dealing with subtraction, so we will be applying the quotient rule instead. Like we did in one of the previous examples, we need to write each log to the default base, which is always base 10. So according to the quotient rule, we reserve every right to condense the left-hand side of the equation. And then we translate. At the right-hand side, 10 raised to power 0 is 1. After cross-multiplying, we have x squared plus 7x plus 12 at the left-hand side and x plus 4 at the right-hand side. We therefore rearrange to have this quadratic equation, which factorizes like this. Hence, x equals minus 4 or minus 2, which are the solutions to this equation. Thanks for watching, and if you want to see more videos like this, click on that subscribe button. See you in our next video. Learn more at MathKey.